Hi, good afternoon, grade 9s. We're going to be taking a look at how to create a linear equation using some of the information that we were working with last week. So our goal today is I can determine the initial value and the rate of change from a word problem, a table, a graph, and a pattern, and use them to create a linear equation. So there's quite a lot going on here today. So we're going to take it one step at a time, and we are going to start with trying to create an equation from a word problem. So let's remember the work we did to make equations in Unit 3 to come up with some equations. For example, number 1, a plumber charges $80 for a consultation fee and $40 per hour for any work that is required. Make an equation for the cost of your bill if the plumber worked 10 hours. Now, in Unit 3, we would have just said, okay, we start with $80 and we have to add $40, and then you guys would tell me that we have to add an N on there because we don't know how many hours we worked. And this is a perfectly good equation for Unit 3. But now we have to add in the second variable here. We have to say that this is an equation for cost. So the cost starts at $80 and then we add $40 for each hour. So if n is 0 hours, then 40 times 0 is 0 and we just cost us $80 for the consultation. If n is 1 hour, we just add 40 once. If n is 2 hours, we add 2 40s, and so on and so forth. So note, there's a starting amount that stays the same no matter how many hours you worked. That's what this is. And then there is a per unit value. So the per unit value is always the one that gets the variable. Per unit. And the variable is the stand-in for the unit. Stand-in unit. We call the starting number the initial value. So this is our initial value. That's the starting value. It doesn't change. We have to pay that consultation fee no matter what. So this is the initial value. And then the per unit cost is the rate of change. And we've been talking about rate of change for a few days now. So the per unit amount is the rate of change. The rate of change needs a variable with it since that is the part that will cause the value of the equation to change. That's what variable means, it's going to change. So here's just sort of a general pseudo math equation that says the amount equals the initial value. So this is the initial value. Initial value. And ROC stands for rate of change. But you knew that because we already talked about that last week. We've already been writing down rock for a while. Okay, so example 2 says, create an equation for the following situations. So Carla pays $15 for each visit to her dog groomers. Create an equation for the amount she spends on grooming, G, after V visits to the groomers. Okay, so we want to take a look here. We want amount equals initial value plus rate of change. Is there an initial value here? Think about it a little bit hard. She pays $15 for each visit. That's a per unit rate. Oops, per unit rate. I don't see anything here that says there's like a consultation fee for her grooming or a subscription fee or a membership fee or anything like that. So it doesn't look like there's an initial value, and that's fine. So the amount she spends on grooming is G. So we're going to use a big G equals, and it's $15 for every visit. So we need to introduce a variable cost with our unit rate, so per unit. So look for these words that are in there. I wrote the word per unit in, but for each visit is another way of saying per visit. So look for that per, even if it doesn't say per, it might say something else. Okay, let's look at the next one. The yearbook costs $3,500 for setup and consultation fees. So there's the beginning cost. This is where we're looking for setup fees or consultation fees. This is a beginning cost. That's our initial value. And $15 for each. There's those words. Those for each is another way of saying per book printed. Create an equation for the cost of the yearbook C. So we're trying to find the cost of the yearbook, and it's going to equal the initial value, the opening cost. They have to pay this $3,500 no matter what. And then on top of that, they pay $15 for each book sold. So if they sell no books, then it's just the $3,500. If they sell one book, it's $3,515. We don't know how many books they're going to sell, so we have to put a B beside that 15 to stand in for what we don't know. Now there's two more on here that I'm going to suggest that you pause this video and try them yourself and then come back. And hopefully you did pause the video and now you're back. So this says, Sveta works at a local gym as a personal trainer. She earns $50 each shift, an additional $35 per hour. This one is tricky because it has an each here and it has a per hour. So it looks like there's two per costs here, but there really isn't, because this says let E represent her earnings and H represents the number of part-time hours or personal training hours. So we're just trying to find out how much she makes in one shift. So since it's in one shift, we don't have to worry about this each shift part going up. This is our initial value. That's what she earns for the shift, and then she earns $35 if she has personal training for people. So this says her earnings for her shift start at $50, and then if she trains somebody, $35 for each hour. What did they ask us to do? H represents the number of hours for each hour of personal training time. So here's our initial value, and here's our rate of change. And this one was tough because it had each shift there, so that kind of looks like a rate of change, but we're only worried about the shift. So that is the initial value for her shift, and then $35 for the personal training. Next one. Matthew's bank account has $500. Each month he spends $50. Let B represent his balance and let M represent the number of months that have passed. So what are we looking at here? Matthew's bank account has $500. That's what he starts with. So that is the initial value. And here's our each. Each month he spends $50. So this is our rate of change. Now you got to be careful with this one, because B is his balance and he's starting at $500. Now all of the ones up till this point have had a plus here, but spends implies that we are going to minus something. So we're going to subtract $50 for every month, and it asked us to use M, so 50M. Okay, so pause the video again and try these ones out. And I'm actually going to pause the video too, and through the magic of the video, you'll just have the answers in a second. So pause it, go through it, and when you come back, all the answers will be here. Ta-da! We're back, and there's all the answers. And there's just a couple that I want to comment on. First of all, if yours don't have exactly the same variables as mine, that's fine. Take a look and make sure that you have the same, that you have variables with the same numbers that I have, and that you have the numbers in the right spot. So the only one here, this plane was descending, so that's why we had a subtraction here. It started at 1700 and went down 50. There was a lot of things here that didn't have an initial value. So if they don't have an initial value, they just have one term here with the variable in it. And I think I think that's about it. If there is any question with this, you can ask me about it in class tomorrow. So we're going to move along. Equations from tables of values. So now that we know how to make an equation using the initial value and the rate of change, we need to be able to recognize the initial value and rate of change in different situations, starting with a table of values. So here, we already know how to find rate of change. We've done that. We have to figure out what the x's go up by and what the y's go up by. Although these aren't going to be x's and y's, we're going to have different letters in here, but still, we have to do our rate of change. So, the x's are going up by 20. And the y's are going up by, it looks like 7. Yep, $7. So the rate of change, remember, is the change in y divided by the change in x, which is 7 divided by 20. So 7 divided by 20, since we're talking about money here, we're going to change this into dollars and cents. This is just 35 cents. So 0.35, 35 cents. Now, what about the initial value? The initial value is what it starts with. So it starts when your x value is 0. So this is what you're looking for. You're looking for your x column. So this is your x column. This is your y column. You're looking for a 0 on your x column, and then your y will give you the initial value. So the initial value in this one is 2.5. So remember, wherever your x starts, that's your initial value. So for this one, the initial value is 2.5, and the rate of change is 35 cents. Now, we can create an equation from this then, because if this is our initial value and our rate of change, then we can say that the cost, which is what our y value was, this is cost, and this is kilometers driven, so let's let it be K for kilometers. The cost starts at $2.5, and it increases by 35 cents for each kilometer you drive. And there's our equation. Okay. What about this table, though? This table has a bit of a problem because we can't see the initial value. So we want to find the rate of change and the initial value and create an equation. This one might be a little bit tough. Let's find the rate of change. So it's still going up by 20 over here. And over here, it looks like it's going up by 5s. 5, 5, 5. So the rate of change is easy enough. Remember, rate of change is what our y's go up by over what our x's go up by. So this is our x and this is our y, our independent and our dependent variables. Cell phone bill depends on how many long distance minutes you use. So 5 over 20. 5 divided by 20 is a quarter, so 0.25. So that's our rate of change, but what was our initial value? We've got to get back to 0 somehow. So how many jumps would it take to go back to 0? I would jump once, and that would take me back to 20, and then I would jump again, and that would take me back to 0. So I need 2 jumps over here. So 2 jumps over here, I go back 5 and go back 5 again. So I have to go back 10. So this is going to go back to 20. So the initial value would be 20 if I follow the pattern backwards. That means that our cell phone bill costs $20 to start with, and we are going to increase that by 25 cents for each long distance minute. Now, following the pattern back isn't the only way that we could have figured that one out. I'm going to give you a little alternate. We're going to call this an alternate method. because following the pattern back might be a little bit difficult. So say we don't know what that initial value is. Let's just say we know that the cost equals an initial value to start with plus 25 cents per minute. So just pick one of these things in here and figure out and plug in for your cost and your number of minutes, and we'll figure out the initial value. So the cost is $45 for 100 minutes. Let's just do that one. The cost is 45 for 100 minutes, 0.25 times 100. So we can use our algebra skills, and we know that for this one here that we're looking at, $45 equals the initial value plus 100 times 0.25 is $25. And if I just subtract 25 on both sides, we can see that the initial value was $20. Okay. So you can use your algebra. This is using algebra to figure out what that initial value is if you can't see it in the table. Okay, so moving right along, let's take a look at another one. Find the equations for the following tables. So this one looks good. We've already got a 0 here. If this is my x and this is my y, we've got a 0, so we know it starts at 100. Let's figure out our rate of change. So this is going up by 1, and this is going down by 20. So this means our initial value, which we figured that out, is 100. We found the 0. The initial value is 100. The rate of change is the change in y over the change in x, which is negative 20 divided by 1, which in this case is just negative 20. So if we want to take our equation, let's just use x and y here. Y equals the initial value, which is 100, subtract 20 times x. So this is our initial value, and this is our rate of change. Let's do this again. This is going up by 1. We kind of like when it goes up by 1. This one's going up by 2. So do we have an initial value here? It doesn't look like we have an initial value here, but there's only one jump back to get what our initial value is. If I subtract 1 here, that's going to go to 0. So I have to subtract 2 here, which means that this is going to go to 10 up here. So our initial value equals 10, and our rate of change equals what our y's go up by over what our x's go up by, so it's just 2. So if we're letting this be our y and this be our x, y equals our initial value of 10 plus 2 times x. Next one. This is a nice one. We've got a 0 in here, so I know what my initial value is. The initial value is 0. This is going up by 1. Have you noticed yet that if this goes up by 1, then the rate of change is just what this side goes up by? So it's kind of nice if this side goes up by 1. This side's going up by 6 each time, so that means our rate of change equals 6. As long as this side goes up by 1, this is actually our rate of change. So if this is our x and this is our y, y equals, initial value is 0, plus 6 times our x, our rate of change times our x. And maybe you want to pause the video and do this one on your own and see how it goes. I'm going to carry on and do it, but hopefully you paused it and you're back. So we're going to do this one with the algebra method. This is going up by 20s. And this, actually, I think this is exactly the same one we did a minute ago. We won't do that one again at all. I'm just going to double check. Is that the same one we did? It's exactly the same one we did. We're not going to do that one again. Did you recognize it from before when I told you to pause the video? Okay. I actually think I'm going to leave that there for today. We're going to go on and do the graphs tomorrow, but for right now, I'm going to let you stop there and we'll let you have some time to get your homework done. If there's any questions, you can ask me in class tomorrow.